So imagine the greatest value of a picture is when it forces us to notice what we never expected to see. So imagine if that picture is 3 dimensions. That's what virtual reality is going to bring to you. Here's another observation by Greg Nichols from a few years ago of ZDNet. 3D visualizations in mixed reality are the right tool at the right time to help decision makers understand and glean insights from huge data sets. Consider some of the commentary and observations made by Professor Gunnar Carlson, who notes that topology is something that's ripe for 3-dimensional understanding. Understanding the topology or the shape of your data. We use our visual system to look at the data and identify features in the network which correspond to patterns in the data. With the 3-dimensional view, you leverage your brain's natural ability to understand multidimensional space. Consider this visualization from the NASA Health and Human Performance Directorate at Johnson Space Center. This is a view of 4 different long-duration spaceflight risks and how they interplay. They've constructed risk portfolio graphs to help them understand how the risks of long-duration spaceflight interplay with each other. Stability, medical, fracture, renal. When you put these together into a single graph, as they actually are, and start animating through them in stages, your brain begins to see that this is in fact a 3-dimensional construct that has been flattened for 2-dimensional viewing on a monitor. You're actually in a 3-dimensional construct with this data. The challenge with graphs can often be that dense graphs become impenetrable. You can find yourself having a hard time seeing patterns or seeing the interplay of your elements because there's just so many, especially when you're trying to look at these in 2D. How many monitors can you deploy on your desktop before you simply cannot make sense of it all? So what does AVR graph do? What does virtual reality do? It takes you from a 2-dimensional view of your data to a 3-dimensional view. And this is actually a data set of NASA's of some of the NASA risk data that I brought into Neo4j and modeled it. You'll see that some elements have multiple connections to each other. This was an early visualization of this. The graph is deployed in virtual reality by means of what's called a force-directed graph, which most of you are doubtless familiar with. In a force-directed graph, nodes that are linked by relationships pull together. Nodes that are not linked repel each other. And in virtual reality, the Unity virtual reality development environment is used to leverage physics to accomplish this in 3-dimensional space. At some point, when you deploy a graph, the total energy in the system reaches an equilibrium and the rendering begins to stabilize, and it doesn't wobble in space. It becomes very, very still. Visual cues also help you to understand the graph. Nodes are color-coded by type, of course, and relationships likewise. Multiple relationships between the same pair of nodes are rendered as Bezier curves so that you can see them rather than single lines on top of each other. Because directionality matters in Neo4j, depending on the data set, directionality is indicated by flowing chevrons, and that you can also add a weight property to your relationship, which will determine how fast the chevrons scroll and how brightly they are colored. If they're less significant, lower weighted, then they will scroll more slowly and the colors will be desaturated. Centrality particularly reveals itself easily in a 3-dimensional graph. Centrality is indicated when nodes that have more relationships wind up in the center of the graph. Nodes that have fewer relationships get pushed to the perimeter. And isolate nodes that have no relationships connected to them at all wind up on the outside the graph. It's an easy way to visually see, are there flaws in your data, because you may be expecting connections that you don't see rendered because they're just not there. They haven't been entered into your data set. The analyst can down select among relationships and node types. You can bring up information panels to study the metadata about particular nodes and relationships. You can pin nodes in space and adjust the physical spacing and arrangement of your graph. You can hide nodes of a particular type. And most significantly, you can teleport yourself. If you ever spent time in a virtual reality environment, you know that this is one of the ways that you navigate in the 3-dimensional space. You can walk for short distances and you can teleport yourself with your controller to look at your data from different perspectives in different locations. So this is an example of the movie graph. I'm going to switch screens here. And in this demonstration here, this is Neo4j's sandbox movie graph. You'll see the analyst here is down selecting different relationship types. A person can be connected to a movie either as a producer, as an actor, as a reviewer, as a writer. Some actors, here's Meg Ryan with all the different movies that she's been in. But this analyst here is going to start studying Jerry Maguire. The movie Jerry Maguire, you see the relationship with Cameron Crowe there. It's about to be pinned in space. That person has 3 different relationships with the movie because Cameron Crowe served as a writer, a producer, and the director of the movie, bringing all the other actors close up into the space here. The next thing, I'm going to skip a little bit ahead here because you'll see them kind of being repositioned. What the analyst can also do is point the laser controller at nodes and relationships and bring up information panels about those particular elements. So any other metadata that's stored in the Neo4j property graph is brought in to the virtual reality visualization. And again, of course, you can move things around to make it easier to understand what it is that you're looking at. So to give a high-level overview, this is the high-level view of the architecture. You have your outside repository. Some of the work that I've done involves bringing data into Neo4j via text files or via Python utilities that I build. APOC calls you and Cipher queries pull the data out of the property graph database and bring it into virtual reality using Neo4j's Bolt protocol. This enables you to pull from a database whether or not it's local or cloud-based in Neo4j's Aura product. The substantial development of this product occurred as part of an Air Force project. Some of you may have some familiarity with small business innovation research programs or science technology transfer programs that various federal agencies participate in. And as part of a partnership between a prime contractor, Agile Data Decisions, a data science consultancy here in Houston, and the University of Illinois Urbana-Champaign, Aviar Technology built out the capabilities to expand Aviar Graph from just a few hundred nodes to thousands of nodes of capabilities and far more capabilities in terms of down select, bringing in data, doing custom configurations of your interrelationships with your data set. The purpose of the project was to evaluate test and evaluation documents and visualize requirements data flows from a requirement definition to a test definition. So the partner company, Agile Data Decisions, would extract unstructured data using their proprietary technology. Then Aviar Technology built the utilities that brought that data into Neo4j and then rendered it in virtual reality, making it easy to explore. This is a sample of that data. And in this, you see 3 different documents indicated as red nodes. Requirements are defined in a document that aircraft shall fly above 30,000 feet at a speed of 600 knots is an example of a requirement. Some of them are binary, some of them are quantifiable. What you see on the right there is that you see actually 2 different versions of the same document. And this graph indicates which nodes were in version 1, but not in version 2, which requirements were defined in version 2 of the document, but did not exist previously in version 1, and which requirements are common to both. So this is a way of understanding the evolution of your document using Neo4j. This is what that looks like in virtual reality. Imagine if that were scores of documents or thousands of documents. In VR, you can down select, you can stand in the requirement set, you can see the interrelationships of the different elements in your data in a 3-dimensional space. So at this point, I will stop and entertain questions. And I appreciate, again, the opportunity to share virtual reality visualization of Neo4j graphs.